Installation SPS2. All type SPS2 breakers are assembled and production tested at factory, after which they are carefully inspected and prepared for shipment. They are shipped completely assembled except for the 4 legs, which are to be attached during installation at the site. If the breaker is not to be placed in service immediately, refer to the instruction manual for storage recommendations. Here is a list of the suggested material and equipment required for the installation of the Type SPS2 circuit breaker. These are not part of the installation kit provided by Siemens. The breaker should be installed with sufficient space for cleaning, inspecting, opening doors, and removing the interrupters. Refer to the outline drawing located in the pocket of the mechanism cabinet door. The foundation should be prepared before the breaker arrives and should be level within 1/4 inch of the 4 stud locations. The breaker must be lifted in order to attach the 4 legs. On 72 kilovolt and smaller breakers, lifting is accomplished by attaching 3 9-foot hook chains to the 3 lifting lugs mounted on pole units A and C. The 121 kilovolt and larger breakers require 4 9-foot hook chains attached to lifting lugs on the frame. The legs should be first assembled to the breaker, then the breaker assembly bolted to the foundation. Bolts should be firm but not tight to allow proper alignment. Insert shims if necessary under the legs to level the breaker before tightening the foundation bolts. The circuit breaker should be level so that moving parts within the breaker can operate freely. When the breaker and legs are properly aligned and leveled, tighten the leg bolts to 51 foot-pounds and the foundation bolts to 400 foot-pounds. 2 NEMA standard ground pads are located on the breaker frame, one on the left side and one on the right side. 1 NEMA standard ground pad is located on the cabinet. A connection should be made from these pads to the station grounding network. All joints must be cleaned, bright, and free from burrs or surface roughness. The grounding conductors should be capable of carrying the maximum short circuit current for the duration of the fault. Controlled wiring and current transformer wiring can now be attached. Refer to the diagram located in the pocket inside the control cabinet door. Installation: filling the breaker with SF6. Chemically, SF6 is one of the most stable compounds. In the pure state, it is inert, non-flammable, non-poisonous, odorless, and produces no harmful effects on personnel. Each breaker is shipped with a positive pressure of approximately 3 to 5 psig of SF6. The outside density gauge does not resolve to this level, so in order to verify, attach the small pressure gauge that is shipped with the breaker to the outside density gauge fill port. If for some reason it is less than 3 psig, please contact your Siemens representative. Use the hose and fittings shipped with the breaker to connect to the SF6 cylinder. Attach the quick disconnect fitting, then securely connect the relief valve manifold assembly. The pressure relief valve will prevent overpressurizing the hose or the circuit breaker if the SF6 gas cylinder valve is opened excessively. Take the end of the hose with the relief valve manifold assembly and connect to the SF6 cylinder. The procedure for connecting the hose is critical to assure that SF6 is not lost from the breaker or that air is emitted into the breaker. Loosen the disconnect fitting, then crack the SF6 cylinder valve, allowing SF6 to flow out the loosened fitting long enough to purge air from the hose. Close the valve and tighten the quick disconnect fitting. Connect the hose quick disconnect fitting to the breaker. The circuit breaker service connection and the hose quick disconnect are matching fittings which are both sealed when disconnected. When connected together, the seals are opened, allowing gas to flow. Open the SF6 cylinder valve, slowly transfer SF6 into the breaker. The amount of SF6 gas required to fill the breaker varies with the kilovolt and kiloamp rating. When the proper fill level is reached, shut off the SF6 cylinder valve and disconnect the quick disconnect fitting. Reinstall the cap on the breaker service fitting. Check the fill level after 24 hours to ensure correct reading is made. Installation. Final inspection. The Type SPS2 breaker has been completely assembled, tested, and inspected at the factory. However, to preclude possible break or malfunction due to shipping damage, it is recommended that a final check be made for loose hardware, wire connections, and locking devices. Installation. Final tests. An effective maintenance program begins at the installation, which a detailed checklist is inside the instruction manual. This information is then used as a baseline reference for future maintenance and should be a permanent record for each circuit breaker. This should be the complete records of installation, inspection, and maintenance work performed. Installation, final tests, timing tests. With the breaker open and the closing spring discharged, attach the travel transducer to the spring operator mechanism. A travel transducer may now be clamped into position with its rod attached to the space on the linkage gear. Perform one trip operation. If the contact part time exceeds 26.0 milliseconds, there may be excessive voltage drop in the DC control cable to the breaker. Delta time of T-2 milliseconds should be included. In some breakers, opening of the main contacts may be followed in one or more pulls by intermittent touching the arc ring and stationary contact. This would appear on the trace as a reclose or bounce for up to 3 milliseconds. This is completely normal and not cause for concern. Perform one close operation and measure contact make time. Contact make time should be 47 to 63 milliseconds. Delta time of 3 milliseconds should be included. As with the open operation, arc rings touching the stationary contacts may result in premature intermittent indication of contact make up to 5 milliseconds before actual contact make. This too is normal and no cause for concern. Perform one open-close-open operation. Measure the reclose time and the end contact time. Unless specifically ordered otherwise, the reclose time will be approximately 10 cycles. If a special reclose time was ordered, an adjustable time delay relay will be provided. Adjust this relay if necessary to obtain the desired reclose time. In contact time should be 20 to 40 milliseconds. If a substantially different time is measured, check the angular position of the auxiliary switch 52A contact in the trip circuit. This contact should be positioned in a horizontal plane with a breaker in the open position. Refer to the instruction manual for auxiliary switch adjustment instructions. Installation. Final tests contact resistance. Measure the contact resistance terminal to terminal with testing device of 100 amps DC source. Record the contact resistance of each pole to provide a permanent baseline reference against which future measurements can be compared. In diagnosing impending problems, the change in contact resistance in time is far more significant than the absolute value of the resistance. Maximum values for new contacts are 150 microohms. Installation. Final tests pressure switch. Verify the alarm and cutout pressures of the temperature-compensated pressure switch. The contacts operate on falling pressure. Isolate the pole units by closing the shutoff valve and connect a continuity device to cross each contact in turn. Attach bleeder valve that shipped in your breaker kit. Drop the SF6 pressure using the bleed valve. Record the alarm and cutout pressures with the ambient temperature and refer to the chart. The pressure should be the equivalent of 57 to 75 psig at 68 degrees for the alarm contact and 51 to 72 psig at 68 degrees for the cutout contact. When pressure readings are completed, open the shutoff valve and replace any SF6 gas lost in the testing process. Installation. Line connections. Line connections, either flexible or rigid, should have sufficient support to limit the load on the bushings. The conductors and connectors must have adequate current carrying capacity to prevent heat transfer into the breaker bushing. The terminal plates are made of aluminum. Make sure to firmly tighten the connecting bolts.